Hey everyone, and welcome back to DevOps Corner. Let me paint you a picture. It is 3 a.m. Your app is down. The dashboard is a sea of green. The container says it's running, but every single one of your users is getting an error. You try to jump in, to see what's wrong. You type docker exec, and it just fails. There's no shell, no tools. You are completely blind. Now, if that sounds familiar, or frankly like your worst nightmare, then you are in exactly the right place.
Look, you've probably built a Dockerfile that works on your machine. We all have. But there is a massive, massive gap between a container that works and one that is truly production ready. So that's what we're going to do in this explainer. We're going to close that gap. We'll cover all the essential tips, tricks, and these battle-tested practices that most developers just overlook, transforming your good enough Dockerfiles into something professional, secure, and efficient that can actually handle the real world.
Okay, let's dive right in with the first major red flag of a non-production Dockerfile: bloated images. It is shockingly easy for a simple Node.js app to somehow balloon into a 1.2 gigabyte Docker image. In development, you might not even feel the pain, but in a production environment, this size is a massive liability. It makes your CI/CD pipelines just crawl. It racks up your storage costs. And if you're auto-scaling, it can mean new containers take a dangerously long time to start. And worst of all, it dramatically expands your potential attack surface.
Now here's where most people get this wrong. They start with a default base image, something like node.latest. But that image is built for convenience, not for production. It's got a full operating system with compilers and libraries you just don't need to run your app. The first step to a professional setup is switching to a minimal base image. Just by changing one line to Node 20 Slim, or even better, Node 20 Alpine, you can slash your image size by over 80%. This is one of those small tricks that makes a huge difference in production.
But what if you want to take it to the next level? Almost nobody talks about this, but for the ultimate in security and minimalism, you can use Google's distro-less images. These are a total game changer. They contain literally nothing but your application and its direct runtime dependencies. There is no shell, no package manager, not even ls or cat. An attacker who gets access inside this container has literally no tools to work with. It's a more advanced technique for sure, but it is the gold standard for production hardening. So the next mistake is sending way too much stuff to the Docker daemon in the first place. This is what's called the build context. Here's a quick win that so many developers forget: the Docker ignore file. Without it, you're sending your entire project directory, including your local node modules, your whole .git history, log files, over to be processed. A Docker ignore file works exactly like .git ignore. It lets you exclude all that junk. It's a small thing, but it speeds up every single build.
Okay, so we've shrunk the image. Now let's talk about build speed. You've been there, right? You change one line of CSS and your build takes a full 2 minutes. Why? Well, the answer is layer caching. Every single instruction in your Docker file, copy, run, add, creates a new, unchangeable layer. Docker is actually incredibly smart. If nothing in an instruction has changed, it reuses the cached layer from the last build, which is almost instant. But the moment a layer changes, it and every single layer after it are rebuilt from scratch.
And this is a subtle mistake with huge consequences, where developers get the order completely wrong. They start by copying all their source code with copy ... and then they run npm install. So what's the problem here? Well, your source code changes constantly. So every time you fix a typo, the copy layer is invalidated. And that means the run npm install layer right after it is also invalidated, forcing a complete, slow re-download and reinstall of all your dependencies every single time. This is why your coffee break happens during every minor code change.
So, the crucial point, the golden rule of Dockerfile ordering, is this. Order your instructions from least to most frequently changed. First, you copy only your package JSON and lock files. These define your dependencies. They almost never change. Then, you run npm install. Now that layer will stay cached almost all the time. Finally, at the very end, you copy the rest of your source code. This simple reordering is a professional-grade setup that can take your build times from minutes all the way down to mere seconds.
Now for what is arguably the single most powerful feature for building production-ready containers, and it's really the defining line between an amateur and a pro Dockerfile: multi-stage builds. This is a fundamental concept most basic tutorials just gloss over. The core idea is to create a complete separation between your build environment, which is full of heavy tools and dev dependencies, and your final lean runtime environment.
Okay, let's walk through this, because the concept is brilliant. In the first stage, we give it a name, something like AS Builder. Here, we use a full-featured node image, we copy all our code, we install everything, including heavy dev dependencies, and we run our build command.
This stage can be messy and huge. That's totally fine. Then the magic happens. We start a completely new, fresh stage from a super minimal image like an Alpine base. And using this one command, copy from builder, we can reach back into that first stage with surgical precision and pull out only the compiled assets we actually need to run the app. And this just brilliantly illustrates the result. Your source code, dev dependencies, compilers, test runners, it all gets thrown away. The final image contains nothing but the essential application artifacts and a lightweight server. This is a total game changer. And it's not just about size, it's a huge win for security. By ditching the entire build toolchain, you've massively shrunk your attack surface. It's common to see an image go from over a gigabyte down to just 50 or 60 megabytes with this one production best practice.
Hey, if these kinds of pro-level techniques are what you're here for, take a quick second to like this explainer and subscribe to DevOps Corner. We have a lot more content like this on the way to help you build some really battle-tested systems.
All right, we've made our image small and fast. Now, let's make it secure. And we have to start with the single most dangerous and commonly overlooked mistake. By default, processes inside a Docker container run as the root user. This is like leaving the front door of your house wide open. If an attacker finds a vulnerability in your app and gets shell access, they now have root privileges inside that container. From there, they can try to escape to the host machine, and now you've got a major breach on your hands.
The fix for this is surprisingly simple, yet it is an absolutely critical part of a production-grade setup. You just need to add a couple of lines. First, create a dedicated unprivileged user and group. Then, right before your CMD, you just switch to that user with the user instruction. That's it. This tiny two-line change can save your company from a major breach by enforcing the principle of least privilege. Now, if your app is compromised, the attacker is trapped as a low-permission user, which dramatically limits the damage. If you're running this in production, this matters a lot.
All right, next up on our security checklist is a question that should make you pause and think. How are you handling secrets? I'm talking about your API keys, your database credentials, and all your private certificates.
Let's be crystal clear about the hard and fast rule here. Secrets never, ever belong inside your Docker image. Don't bake them in with env instructions, don't copy secret files into the image, and please, certainly don't commit .env files. Anyone who gets a copy of your image can simply run docker inspect and extract your secrets in plain text. The only production-ready approach is to inject secrets at runtime using your orchestrator's secret management system, like Kubernetes secrets, or by mounting them as secure volumes.
You can't fix a vulnerability you don't know you have. That's why another key to a battle-tested environment is integrating automated vulnerability scanning directly into your CI/CD pipeline. Tools like Trivy or Docker Scout can scan your image for thousands of known security holes, or CVEs, and you can configure your pipeline to actually fail the build if a critical vulnerability is found, effectively creating a security gate that stops vulnerable code from ever reaching your users.
Let's talk about production stability. Using the latest tag, it's just a recipe for disaster. That tag can change. The image it points to can be updated tomorrow, and suddenly your builds start failing because of some upstream change you didn't even know about. A good practice is to pin to a specific version tag, like Node 2011-Alpine. But the absolute best practice, the key to real production stability, is to pin to the immutable SHA-256 digest. This digest is a unique fingerprint of that exact image. It guarantees your build today and your build 6 months from now will be absolutely bit-for-bit identical.
Now, a quick but important clarification on two instructions that often confuse developers, entry point and CMD. Think of it this way. Entry point defines the container's main executable, its core purpose. CMD provides the default arguments for that executable. So for example, your entry point could be ping, and your CMD could be google.com. This makes your container executable and flexible. Someone can just run docker run my image and it'll ping google.com. But they can also easily override that default, like this, docker run my image yahoo.com, and it'll ping Yahoo instead. The argument they provide simply replaces the CMD.
So let's bring this all together for a second. We've followed all the best practices. We have a tiny, fast, secure container. We used a distroless image, so it has no shell, no package manager, no debugging tools. We've built the perfect fortress. Which brings us right back to our opening nightmare scenario. How on earth do you debug it when something goes wrong? Are we locked out too? The pro-level trick here is that you don't debug in the production container at all. Instead, you use what's called an ephemeral debug container. You launch a separate, temporary container that's packed with all your favorite tools, curl, netcat, TCP dump, whatever you need. Then you attach it to the same network namespace as your production container. This lets you inspect traffic and diagnose issues without ever contaminating your lean, secure production image. And when you're done, you just delete the debug container, leaving no trace behind. It's a clean, secure, and really powerful technique.
So, let's quickly recap the key battle-tested best practices we've covered. Always start with minimal base images like Alpine or Distroless. Use multi-stage builds to separate your build and runtime environments. Carefully order your Dockerfile instructions to maximize that layer caching. Always run your containers as a non-root user. Manage your secrets externally, never bake them into the image. And finally, pin your image versions using specific digest for maximum reliability. These are really the pillars of a professional Docker setup.
By applying these tips, you've now elevated your Docker skills from just making it work to building truly professional production-ready containers. They're smaller, they build faster, and they're significantly more secure. But this solid foundation is just the beginning. These practices become even more critical when you move to the next level with powerful orchestration tools like Kubernetes, where you'll be managing hundreds or even thousands of these containers at scale.
If you found this deep dive helpful and learned some insider knowledge you can apply to your own projects, make sure to like and subscribe to DevOps Corner. We'll be back with more explainers to make you a better engineer. Thanks for your time, and now go make your containers production ready.